All right, last lesson of this unit. It's over inverse functions, and yes, we've already done this before. All right, so for inverse functions, remember this is just when x and y switches places, and we'll see that later. So to tell whether a graph has an inverse that is a function, we're going to use our horizontal line test. So I'm going to draw a horizontal line, and what I'm going to do with this is I'm going to drag it up and down. So you can take your pencil or finger or whatever, and drag it up or down your graph. You see how here this red line touches my purple graph pretty much twice at any given point. There it touches twice, there it touches twice. The very bottom it only touches once. Because it touches the graph more than once, then no, the inverse of this graph is not a function. So I'm going to take this line and move it over to my other graph. So if I look at this blue graph, when I go up and down, my red line only touches my blue graph once at any given moment. So that tells me that the inverse is a function. So for this last graph, I'm going to do the same thing. And if you see here, it touches 3 times. Down here, it only touches once. Up here, it touches 3 times. Down here, it touches like 1, 2, 3, 4, 5 times. No, the way up here only touches once. But because it touches more than once at any given point, no, the inverse of this graph is not a function. All right, so a couple things to remind you guys about. To find the inverse of an equation, this is what we've done before. This is where it's always going to say f of x because it's a function. So I'm going to replace f of x with y. Then remember that's where we always get x by itself, but then we switch x and y back. So remember that this is where inverse is where x and y always switch places. Over here I gave you a table of when you're solving, you know, if it says x plus 3, then we know to subtract 3. If you have x squared, that's where you take the square root. And the difference is we're adding in problems that have exponents, exponentials, and logs. So our first examples we're going to keep pretty simple. So remember step 1 says replace f of x with y. And then we're going to solve for x. So the way my freshmen like to see it is I box in what I'm solving for, and everything that is on the same side as x has to move to the other side. So I get rid of what's furthest from my x first. So subtract 5. So I have y minus 5 equals 1/3 x. And you all right now are freaking out because there's a fraction in your problem. But I know that 1/3 is the same as dividing by 3. So my inverse is to multiply by 3. So those cancel and I'm left with x. And I'm going to distribute this 3 in. So that's going to be 3y minus 5. Your last step is to switch x and y. So I'm actually going to do y equals 3x minus 5. And to rewrite it as a function, I do my f inverse. Over in this problem, I have x to the 3rd minus 2. So again, I'm going to do y equals instead of f of x, just because it makes the problem look easier. I need to solve for x, so I'm going to get rid of everything that's outside of the box. So I get rid of the minus 2 first, so y plus 2 equals x to the 3rd. And if you look back at the table we wrote from the last page, anytime you have a power or anytime you have an exponent, you're going to use that root. So since it's x to the 3rd power, I'm going to take the 3rd root. You can't just take the square root because that's not the inverse. The 3rd root's the inverse. So the 3rd root and the exponent of 3 cancel each other out. And there's nothing I can do over here, so I'm just going to write it as the 3rd root of y plus 2. So I'm going to do y equals the 3rd root of x plus 2, and then you can rewrite that as a function inverse. So hopefully those steps ring a bell and you kind of remember what you're doing. So you just have one try on your own problem, 2x minus 1 all over 7. You need to find its inverse. Good luck.